Hello guys, welcome once more to class online, and my name is Mr. Damilola. Now in this video we are looking at Jamb physics number 2019 and number 26 to number 30. Now this is the video that where we simplify physics and we make it practical, what you can relate with, and we also help you to emphasize the important formula that will make you a winner. Because for you to be here online watching this kind of video, that means you are a winner. Let's check out number 26 to number 30. Now don't forget that if you really enjoy this video, click on like button so that you can get more stuff from us from time to time. Now let's check out the number 26 now. Number 26 says the diagram above shows a magnet with its south pole moved along a soft iron bar PQ in the direction as shown. After some time, the pole at Q respectively are what? Okay, now if you move this magnet this way, that means the magnet is going to the left. Okay, it's moving through that surface and it's going back. It's going back. Now take note of the pole that is touching the surface. It is the south pole and it is going this way. Okay, whenever a magnet touches a surface this way, okay, it creates an opposite pole at that point of contact. What I'm saying is that the magnet is going to the left. Okay, so and the head of the magnet, that's the pole touching the other metal on the ground, is south. So that means south will produce the opposite pole, which is north. So this magnet is going to produce north pole because it is south pole. You know, opposite pole, the law of magnetism says that opposite pole attract while like poles repel. So this is south pole, it will attract north pole. So this is south pole, it will produce north pole at that direction it is going. So it will produce north pole in that direction. So the question said after some time at this is it is moving from P to Q, right? After some time the pole at Q respectively are what? So the pole at Q this is moving from north. Now this is the diagram. South moving in, it will produce north and it will produce south in the opposite pole. Then if it is north moving in, it will produce south in that direction and produce north in the opposite pole. So the pole at Q respectively are going to be what? It's going to be north, south pole. This is something this is how do I know that it is north south pole? That rod under is called PQ. That means the rod is from P to Q, right? From P to Q, and the magnet on top is going towards the end of the rod. So it is going towards the beginning of the rod. So it is going towards P side. So it is going to produce respectively at Q. It is going to produce north first. That's north first. So that question is supposed to be PQ. Producing at PQ respectively, it will be north at the direction the magnet is going. It will produce north, then it will now produce south in the opposite direction. So the magnet is going to produce north where it is headed, okay, north first, then it will now produce south in the opposite direction. So that's the way magnetism works. Now don't forget this picture. Magnets produce their own opposite where they are headed. Okay, if it is north, it will produce south where it is headed, then produce north in the opposite direction. But if it is south, it will produce north where it is headed and produce south in the opposite direction. That's where it goes. So this magnet will produce north, south, and that is the answer, option A. So let's check out number 27 now. 27 says a gas will serve as an electric conductor under what? Now, if what condition must occur for gas to behave as a conductor? Now, naturally, gases are not conductor, but there's a way to force gas to become a conductor. What I mean is that now metals can conduct electricity because they are conductors, and therefore, and because they are solid, right? Now, but some liquid like water can also conduct, but can gases conduct electricity? It is only possible in an electric field, and it is naturally not supposed to be. But what is the condition that makes it possible for air or gas to conduct electricity? It is what you have in a bulb. Now, a practical example of that is what happened in a bulb. Now, inside a bulb in a discharge tube, you have when a high voltage is applied to a gas filled tube, the gas become more ionized. Like if you apply high voltage, that's the first condition, to a gas tube, the gas inside become charged. That's ionized. One or more electrons are separated from each other. Since positive and negative charge are present, the ionized gas conduct electricity. The gas atoms are excited and emit light of a color characteristic of the gas. So if the gas is pink, it will produce pink light. And the reason why we have lights that are white is because the gases within the bulb are white. Okay, so and the gases also are charged at high voltage. So in short, gases can conduct electricity, but they are considered insulator for the most part. Gases on its own cannot conduct electricity. Gas on its own can't conduct unless something is done, but it can be made to conduct electricity by subjecting under low pressure and high voltage, and that is what we are looking for. Low pressure and high voltage. So gases conduct electricity under this condition. If the pressure is low and the voltage is high, there will be conduction, and the gas will behave as a conductor of electricity. So that's the question. So carbon is the only gas which solidifies, which when is the only gas when solidified that can conduct electricity. So don't forget the condition. The voltage has to be high and the pressure has to be low for gas to conduct electricity. And that brings us to the answer, making option C the correct answer. Reduced pressure and high, that's supposed to be high voltage. High voltage. That's supposed to be high voltage. Reduced, we have A as reduced pressure and reduced potential. Potential is voltage. It can be reduced potential. Increased magnetic field, reduced pressure and high current. Exposure to visible light. The answer is supposed to be actually reduced pressure and high voltage, not high current. It should be high voltage. So if naturally it seems I don't have the correct answer in this option. It's supposed to be reduced pressure. Take note, reduced pressure and high voltage, and wherever increased voltage or potential difference lowers current. So I can't say high current because it should be low current and high voltage, because current and voltage are like they are not friends. So if voltage is high, current will be low. So it should be reduced pressure and high voltage, not high current, and that gives me my answer. So that's the answer to number 27. Now let's check out number 28 now. If current flow in the direction of the arrow in the slide one above, the north pole is at dash. Now, this question is asking about current and the magnetic field. Now, this can only, the direction of current can only be explained by Fleming's left-hand rule. You know, Fleming's left-hand rule explains direction. It shows you the flow of current. See, this is the left-hand rule. It says that if current flow this way, then the field is this way, and the motion or the thrust is this way. So the direction of the magnet, this is the magnetic field. This is the magnetic field. So if this is my left hand, this is the left hand rule. Okay, current is this way. This for current, that's Fleming's left hand rule. It shows you the direction of current, magnetic field, and motion. Okay, so we have current is here, then this is the magnetic field, and this is the motion. So if the current, like in my question, I have the current is flowing downward this way. Okay, so the magnetic field is supposed to be flowing this way. That means like it is flowing upward. So that's the direction of the magnetic field. Current is here, magnetic field is here, and this is the direction of the motion. So that's brings me to the answer to that question and makes the answer to become Q. The current flow, the magnetic field, that's the north pole, which is a magnetic pole, flows in the direction Q. Just like my hand. Look at my hand. It flows. Current is here. This is my left hand. Current is here, and this is the magnetic field flowing this way, and this is the motion direction. Okay, so that settles. Fleming's left hand rule show us the direction of current, magnetic field, and motion, and that's the function of it. And that will be useful for you if you are a builder or for things like electric motor. You will need to know that because it will help you to build it correctly. Let's check out number 29. The magnetic force on a charged particle moving with velocity is what? Now, this is simply asking about the magnetic force formula. Now, magnetic force asks, there's only one formula in magnetism, and that formula is very important. And that formula is what can answer this question. Look at the formula. Let me show you that. So the formula is just F is directly proportional to QV. Okay, F, that's force, magnetic force is directly proportional to QV. If you know this formula, you can answer any calculation on magnetism. This formula is the only formula in magnetism. Okay, F is directly proportional to QV, where my F is the magnetic force in Newton, my Q is charge in coulomb, and my V is velocity V. That's velocity in meter per second. But if you want to change that directly proportional, it will become mathematical. It will become equal to B, and then that B is called magnetic density, and it is calculated in Tesla. So magnetic. So the formula becomes F is equals B QV. F equals B QV, and that is the magnetic formula which you must not forget, please. You must not forget. Once you ask this formula, you can tackle any question on calculation in magnetism. F equals QV. But the question said the force on a charged particle moving with velocity is what? Now, what's the relationship between the force, okay, and the V? Now, is it option A says proportional to the velocity only, or independent of the magnitude of the charge, proportional to both the magnitude of the charge and velocity? That looks right. C looks right. That means it is the same on a straight line to the charge, that's Q, and the V velocity. And that makes option C the correct answer. Proportional to the magnitude of the charge only. It's not charge only, it's not Q only, it's not V only, it is proportional to force is proportional to QV, and the Q is my charge and my V is my velocity. So my force, magnetic force, is proportional to the charge and the velocity, and that makes the correct answer to become option C. Okay, so that answers that question. Now don't forget that formula is very, very important, and with that formula you can tackle any question on magnetism. Now let's go to the next one, the last one for this session. It says the eye controls the amount of light reaching the retina by adjusting the wall. Now if you have seen the eye, let me show you a picture of the eye. That's a eye, that's a woman's eye there. Now what controls the light coming to the eye? That's just the question. What is the part of the eye that controls the amount of light entering the eye? You know, we have the retina in the option. Retina does not control light quantity. Retina is a light sensitive part of the eye that forms image in the eye. You know, the images coming to the eye are formed at the retina. That's why if I'm looking at you in the retina in my eye, you are upside down. So your image is forming at the retina in my eyes, upside down. But when it's getting to my brain, it will become upright again. So my brain turned the image of you I'm looking at. My brain turned it in the right to stand right. But in my eyes only without my brain, then you are upside down. Okay, because images form at the retina upside down, but it is not the retina that controls the light entering the eyes. Now let's check the iris. The iris is the colored part around pupil, controls the amount of light in. So the answer, that the part that controls the light entering the eye is the iris. Now you know that we have this picture, like some people, the tiny hole in your eye, the smallest hole, that tiny black hole in your eye is called your pupil. Now, but the big black hole around the tiny black hole is the iris. And you know that if the light is too large, is too much, you kind of squeeze your eyes. That means the iris contracts. When the light is too much, the iris contracts in order to accommodate the light so that you can see. Okay, what I mean is that if you are in a dark room and they put on the light suddenly, boom, the first thing that will happen to your eyes is that you will squeeze your eyes. That means the iris will contract in order to adjust to the bright light so that you can see. So the function of the iris is to control the amount of light that enters the eye Full stop. So the answer is iris. The next one we have cornea. The cornea is the window covering the iris and the pupil. The cornea, the function of the cornea is just to cover, so that like it's a tiny skin that covers the iris, that covers your eyes, so that when something gets to your eye, it won't damage your eye. That's the cornea. Then we have the optic nerve, is a link that connects your eye to your brain. That's called optic nerve. It's a nerve, it's a link from your eyes to your brain. So the answer to that question is therefore iris. Is the one that controls the amount of light that enters your retina, and that is the answer. So guys, this brings us to the end of this video. Don't forget, if you really enjoyed this video, click on like button so that you can get more from us that will help you in your journey to understand physics. Until we see you next time, take care of yourself and bye for now.